Hello, my name is Miss Townsend, and welcome to Math with Townsend. This is a by request video for my grade 11 students, and here's the request. Dear Miss Townsend, can you please show me how to do one of those uniform width quadratic word problems? Certainly. Well, let's do it. So here's a question I found online. It says you are making a frame of uniform width for a picture that will be displayed in a museum. The picture is 90 centimeters tall and 100 centimeters wide. The museum has allocated 2 square meters to display the framed picture. What should the width of the frame be in order to fill all of the allocated space? So let's take the question apart piece by piece. You are making a frame of uniform width for a picture. So here's a lovely picture. And if we put a uniform frame around it, it would look something like this. And that's what we're looking for, a frame of uniform width. So uniform width tells us that all of these red markings, the width of the frame, need to be the exact same width. So what is the width of the frame? Well, we don't know. And when you don't know it, that's when you call it x. So each of these red widths is going to be defined as width x. So that's the first step, is to define variable x to be the width of the frame. Now, we're also told that the picture is 90 centimeters tall and 100 centimeters wide. So that's more information that we're going to need. So what we really want to find out now is if the picture is 100 centimeters wide and we have these frame dimensions of x units on both sides, then what's the width of the entire picture with the frame, which I've shown here in a green line? Well, if we start at the left corner, we go x centimeters, then we go 100 centimeters, and then we go x centimeters. So if we combine that together, we can say that the width of the picture, including the frame, would be 100 centimeters plus 2 x's. So 100 plus 2x is the width of the picture with the frame. Similarly, if we want to know the height of the picture with the frame, so that's the green line here, we can say that we have to go x units, then 90 units, then x units. So again, we start at the corner and we go forward x centimeters, then 90 centimeters where the picture actually is, then x centimeters for the rest of the frame. So we can say that the height is 90 plus 2x centimeters. So that means we now know that the dimensions of the picture, including the frame, are 100 plus 2x by 90 plus 2x in centimeters. And that means that since we want to talk about the area of the picture with frame, and it's a rectangle, so area is of a rectangle is length times width, and now we know that the length is here and the width is here. So the area is 100 plus 2x, that's the length, times 90 plus 2x, and that's the width. And if we do a little bit of binomial math, we end up with this expression. The area is 9,000 plus 380x plus 4x squared. So that's my expression for the area of the picture, including the frame. So here it is in summary. There's the picture with its lovely frame, and there's the area that I know. So of course, here's the question you should be asking. How am I going to solve for x? Well, there's more information in the question that we haven't looked at yet, and here it is. We're told that the museum has allocated 2 square meters to display the framed picture. So I'm picturing this. There's a lovely museum wall with some beautiful portraits. And right here, they've allocated 2 square meters to put this new picture with its beautiful frame. But be careful. And I've made this little thing. Be careful, avoid accidents with units. Here's what I'm talking about. The information we're given is that the picture is 90 centimeters tall and 100 centimeters wide. And then we're told that the museum has allocated 2 square meters. So in one sentence, we're talking about centimeters, and the next we're talking about meters. So we're going to have to convert 2 square meters into square centimeters. Here's how we do it. 1 square meter looks like this. It's a square that is 1 meter by 1 meter. But I want this in terms of centimeters, not meters. So 1 meter is 100 centimeters. So now I have a square which is 100 centimeters by 100 centimeters, which is how many square centimeters? Well, length times width, 100 times 100. That gives me 10,000 square centimeters. So 1 square meter is equivalent to 100,000 square centimeters, which means for my picture frame problem, if I have 2 square meters available, that's equivalent to 20,000 square centimeters. So make sure you always pay attention to units and don't mix and match. So here's what I know. Instead of saying the museum has allocated 2 square meters to display the frame picture, I'm going to say that the museum has allocated 20,000 square centimeters to display the framed picture. So I know, based on the uniform frame problem, that the area of the picture, including the frame, is 9,000 plus 380x plus 4x squared. And I know that the area to be filled is 20,000. So both of these areas represent the same shape, which means that 20,000 has to equal 9,000 plus 380x plus 4x squared. And as soon as I write that, I now have a quadratic equation and I can start to solve for x. So of course, in order to solve for x, we know the first step is to make it equal to 0. So I subtract 20,000 from both sides. And then I'm just going to rearrange it slightly because I like having my highest degree term first. And here I can clearly see a quadratic. So I could try factoring, but I'm not going to. I'm just going to use the quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Do that math, and I get x is approximately, because I had to round my radical, negative 380 plus or minus 566 divided by 8. And when I separate that into 2 pieces, I get that x is about 23.25 centimeters, or negative 118.25, and you can see I've already crossed that out of inadmissible. You don't measure in negatives, and you certainly don't measure negative 118 centimeters on a picture that's only 90 centimeters in length. So therefore, we know that the frame should be 23.25 centimeters wide on all sides of the picture. And here it is in my diagram with my lovely picture restored. And of course, it's very easy to check our answer, because now that we solved for x, we can substitute x in to 100 plus 2x and discover that the length of the picture frame should be 146.5 centimeters and the width should be 136.5. And if we do the math on that, area is length times width, and I get an area of pretty darn close to 20,000 square centimeters, which is 2 square meters. And as the banana says, woohoo. So thanks for watching. I got this question from the internet at a website called algebra.com, and I'm Miss Townsend. So thanks for watching, and I hope that helped. Bye.